In this video, we are going to consider translational motion. So a translational motion is a motion that occurs in a straight line. A straight line can be either a horizontal straight line or a vertical straight line. So it means that translational motion can either be a horizontal motion or a vertical motion. If translational motion occurs horizontally, it is known as uniformly accelerated motion. And if it occurs vertically, we commonly call it motion under gravity. For you to solve problem on translational motion, you must be familiar with equations of motion. And these are the equations of motion. One equation says V equal to U plus AT. Another equation says V square equals to U square plus 2AS. Another equation says S equal to UT plus half AT squared. Then we have another equation that says S equal to V plus U over 2 multiplied by T. Now, what do all these parameters means? All these parameters stand for V is the final velocity, U is initial velocity, S is distance covered, T is the time duration for the motion, and A is acceleration. So those are the parameters in the equation and what they stand for. Now in some textbooks, you do not see them this way. In some textbooks, V is written as VF, which is final velocity. U is written as VI, which is initial velocity. And S is written as change in X, which is change in displacement. So you might see this equation as, this first equation, you must see it as V final equals V initial plus AT. And you might see the second equation as V final squared equals V initial squared multiplied by plus 2 times A times change in X. And you might see this one as change in X equals U initial multiplied by T plus half AT squared. Understand that they are the same thing. The equations of motion are derived from definitions of the parameters used in motion. Let's start with acceleration. So acceleration is defined as change in velocity over time. So acceleration is rate of change in velocity. So if acceleration is change in velocity over time, since change in velocity means V minus U, that is final velocity minus initial velocity, it means that acceleration is going to be equal to V minus U over T. And if you cross multiply, this is going to give us AT equal to V minus U. To make V subject of formula, we have V equals to U plus AT. That's the derivation of that equation. And then I'll keep it as my equation 1. I will say V equals to U plus AT as my equation 1. Now, another parameter used in motion is called average speed. So what is average speed? Average speed, V average, is total distance covered over total time taken. So average speed is total distance over total time. And I will represent it as V average equal to S over T. Then again, average speed, since we have two speed, average speed, V average, will be V plus U divided by 2. That is the average of two things. So if average speed is equal to S over T, and average speed is also equal to V plus U over T, let's equate the two equations. So it means that you can say S over T equal to V plus U over 2. And if you multiply both sides by T, this we cancel this. So we are going to be left with S equal to V plus U over 2 multiplied by T. So that is the derivation of that equation. So let's make this equation 2 s equal to v plus u equal to multiplied by t. I'll call this equation 2. Now the remaining equations are obtained from the manipulation of these two equations. So let's look at them. Now moving on to the derivation of the other two equations. The other two equations, as I said before, is obtained from the recombination and manipulation of these two equations. Now starting with equation 2 says s equal to v plus u equal 2 multiplied by t. Now what I will do is to substitute the value of v in equation 1 and substitute t in 2. So substitute v in equation 2. So it means that we are going to have s equal to u plus at plus u over 2 multiplied by t. Combining similar terms, we have s equal to u plus u is 2u. So we have 2u plus at over 2 multiplied by t. If we FOIL the bracket and multiply L2 by t, we are going to get s equal to 2ut plus 80 times t is 8t squared all over 2. Now, if we separate the division, we are going to have s equal to 2ut over 2 plus 8t squared over 2. So this is going to give us 2 cancel 2, we are left with ut. Then you can write this in a fancy way as half at squared. So this is the derivation, that third equation. Now let's see the derivation of the fourth one. As I said before, we are going to get the other two equations from the combination or recombination of the first equation. So starting with equation 2 again. So from equation 2, we have s equal to v plus u over 2 multiplied by t. In equation 1, I'll make t subject of formula. So from v equals to u plus at, we make t subject of formula, we are going to have v minus u over a, because we subtract u from v and divide root 2 by a, we are going to have v minus u over a. Now what we'll do is substitute t in equation 2. So equation 2 says s is v plus u over 2 multiplied by t. So if we substitute t in this, s is going to equal to v plus u over 2 multiplied by v minus u over a, because that's the value of t. That's what we obtain as t. And let's multiply numerators and denominators. So multiplying the numerators, we have v plus u multiplied by v minus u, and denominator will be 2 times a is 2a. What we have as the numerator is what is known as difference of perfect square. So from difference of perfect square, that is difference of perfect square says that we have, I'm going to write it up here, a square minus b square is a plus b, a minus b. That is what is known as difference of perfect square. So we have v plus u multiplied by v minus u is the same thing as v square minus u square over 2a. Now cross multiply. If you cross multiply, we are going to have v square minus u square equals 2as. 2a times a is 2as. Make v subject of formula. We have v square equals to u square plus 2as. We add u square to both sides. So for our fourth equation, this is the derivation. I hope this makes sense to you and you understand how the 4 equations of motion are obtained. Now let's go to the application of the equations. Let's see how we use them in solving problem, and let's practice some questions. Starting with this question says that a car moving with a speed of 90 kilometers per hour was brought uniformly to rest by the application of brakes in 10 seconds. How far did the car travel after the brakes were applied? All right, let's bring out our parameters. So a car was traveling with a speed of 90 kilometers per hour and was brought uniformly to rest. So brought uniformly to rest means that at the end the car stopped. So its final velocity after consideration of the motion, the final velocity v is equal to 0, which means that this 90 kilometers per hour will be the initial velocity. So the car was traveling at 90 kilometers per hour. That would be the initial velocity. It was brought to rest by the application of brake in 10 seconds. So time is 10 seconds. What we are looking for is how far. So how far is distance? So distance is the unknown. Now 90 kilometers per hour does not rhyme with the other parameters because initial final velocity is 0 meters per second. So we have to convert this to meters per second. So converting this to meters per second, this is going to give us 90 times 1000. A kilometer is 1000 meters. Then divided by 3600. So 1 hour is 3600 seconds. This is going to give us 90,000 over 3600. And 90,000 over 3600 equal to 25. So initial velocity is 25 meters per second. Now, out of the 4 equations of motion, the one that have the parameters of v, u, t, and s is s equal to v plus u over 2 into t. So that is the equation we are going to use to solve this equation because it has all the parameters. Now, s is unknown, v is 0, u is 25 over 2 multiplied by 10, which is same thing as 25 over 2 times 10. 2 divided 10 is 5. So we have s equal to 25 times 5. 25 times 5 is 125 meters. So it means that the distance traveled by the car after the brakes were applied is 125 meters. Now here's another problem. Let's look at this problem. This problem says that a train moving at 20 meters per second is brought to rest by the application by applying brakes over a distance of 100 meters. What is the magnitude of its deceleration? So a car was traveling and it was brought to rest. It means that final velocity v is 0 meters per second. Initial velocity u is 20 meters per second. The braking distance or the distance is traveled before coming to rest is 100 meters. So what we are looking for is the deceleration. So deceleration and acceleration are the same thing. The only difference is that acceleration is positive and deceleration is taken as negative because deceleration is acceleration in opposite direction. And the equation of motion that has all these parameters will be v squared equals to u squared plus 2as. Now, since we are dealing with deceleration, I'm going to change this positive to negative. So I'll write it as v squared equals to u squared minus 2as. Now, if you go ahead and use positive, we are going to have the same magnitude, just that we are going to have a negative answer. The negative will mean that the problem is talking about deceleration. I'll stick with negative since we know that we are dealing with deceleration. Now v is 0, so we have 0 squared equals u is 20, so we have 20 squared minus 2 times a times s is 100. So distance covered is 100. So we have 0 squared equal 400 minus 200a. So add 200a to both sides. We have 200a equal 400. Divide both sides by 200. This cancel this. So acceleration is going to equal to 400 over 200. So the deceleration is 2 meters per second squared. So the magnitude of deceleration is 2 meters per second squared, making option A correct answer. Now here's another problem. You can pause the video and solve before we look at the solutions together. The question says a car is traveling at 90 kilometers per hour toward a barrier 35 meters ahead. Right, so let's put that into visual representation. So let's say this is the car. This is the car. It was traveling at 90 kilometers per hour and then a barrier is 35 meters ahead. So let's say this is the barrier. Now, when the brakes are applied, they exert a constant retarding force of 8 kilonewton, right? So a brake is applied and the magnitude of the force of the brake is 8 kilonewtons, which is same thing as 8,000 newtons. On the 1 kilogram car, right, we are given a mass. The mass is 1,000 kilogram, 1,000 kilogram car. What will most likely happen? Since the brake was applied, what will most likely happen is that we are bringing the car to stop because we have a barrier ahead. So if the car is bring to a halt, it means that the final velocity will be 0 meters per second. So we are bringing the car to stop. Final velocity will be 0 meters per second. And then this initial velocity then 90 kilometers per hour, which will convert to meters per second as 90 times 1,000 over 3,600. So 90 times 1,000 over 3,600 will give 25 meters per second. Right? Now, since the car is stopping, the logical thing we need to do is to find the braking distance. Because looking at the option, we have that the car will stop immediately as option A, the car will stop just before the barrier as option B, the car will stop approximately 5 meters before the barrier as option C, and option D says that the car will stop 5 meters after the barrier. So let's find the braking distance. Let's find the distance the car will travel before coming to rest. So it means that we are looking for S. S is the unknown. All right. Now, which equation has all these? We probably will choose v squared equals u squared plus 2as. That means we need the deceleration, or we need A. So how do we get A? Since we are given force and mass, we can just simply use the equation that says F equals to ma, because that's the equation connecting mass and acceleration and force. To make A subject of formula, we have F over m. The force is 8,000. The mass is 1,000. So 8,000 over 1,000 is 8 meters per second squared. That's the magnitude of the deceleration. So let's put that into our equation. We have v squared equals to u squared. I'm going to change this to negative since we are decelerating, minus 2as. Let's substitute into the parameters. Final velocity is 0, so 0 squared equals initial velocity is 25, so we have 25 squared minus 2 times acceleration is 8 times s. So we have s equal to 25 squared over 16. So this is going to give us 625 over 16, and this will give 39.0625. So the distance the car will travel before coming to stop with 39.1 meters. Now let's apply this into our problem. So the barrier was 35 meters ahead. When the brakes were applied, the car will stop 39 meters, 39.1 meters, which means that the car will pass the barrier. And then the distance between the barrier and where the car is stopping will equal to 39.1 minus 35. So 39.1 minus 35 is 4.1 meters, which means that the car stops approximately 4 meters after brakes were applied. Looking at the option, the most logical answer to pick is option D, because that's the only option that says that. So this question says that the distance covered by an object in the 6 and 8 seconds of motion are 45 meters and 53 meters respectively. All right. So when you see a question that says distance covered in a particular time or during a particular time, the formula for calculating distance in a particular time, not at the end of that time, not at the completion of that time, if it is in that seconds or during that seconds, use the formula Sn equal to u plus a over 2 into 2n minus 1, where n is number of time. So if we have distance in the 6 seconds to be 45, it means that we are going to say 45 equal to u plus a over 2 multiplied by 2 times number of seconds is 6, so 2 times 6 minus 1, which is same thing as u plus a over 2 into 2 times 6 is 12. 12 minus 1 is 11. So we are going to have 45 equal to u plus 11a over 2, and I'll multiply all 2 by 2, cancel out the fraction. So 45 times 2 is 90 equal to 2u plus 11a. The distance covered in the 6 seconds is going to be 90 equal to 2u plus 11a, and we call this equation 1 because u and a are unknown. Now distance covered in the 8 seconds, s in the 8 seconds is 53 meters. So 53 equal to u plus a over 2 multiplied by 2 times 8 minus 1. So 53 equal to u plus a over 2. 2 times 8 is 16. 16 minus 1 is 15. And then I'll multiply all 2 by 2, cancel out the fraction. 53 times 2 is 106 equal to 2u plus 15a over 2 times 2 is 15a. So let's call this equation 2. Now we have a simultaneous equation. Now let's solve the simultaneous equation. So 90 equal to 2u plus 11a. 106 equal to 2u plus 15a. Let's solve this equation using elimination method. So subtract equation 2 from equation 1. 106 minus 90 will give negative 16 equal to 2u minus 2u is 0. 11a minus 15a is minus 4a. So negative 16 equals 0 minus 4a is minus 4a. So let's divide both sides by negative 4. So this cancels this. Negative 16 by negative 4 is 4. So acceleration is 4 meters per second squared. To find u, let's substitute the value of a in any of the equation. So using equation 1, 90 equal to u plus 11a. So we are going to get 90 equal to 2u plus 11 times 4. So we have 90 equal to 2u plus 44. Subtract 44 from both sides, we have 90 minus 44. So 2u equal 90 minus 44 will give 46. So u equal 46 over 2, and u is 23 meters per second. So a is 4 meters per second squared. U is 23 meters per second. Looking at the option, correct answer is going to be B. So what you need to know is the formula for calculating distance covered in the particular seconds. And that formula is Sn equal to U plus A over 2 into 2n minus 1. Now we have a question on a vertical motion. And the question says that a stone is thrown vertically upward with an initial velocity of 15 meters per second. How long will it take to return to the point of projection, taking g as 10 meters per second squared? Right? Now, note that whenever you have a vertical motion, right, or motion under gravity, in the equations of motion that we have, all the acceleration will be changed to due to gravity. That is, for horizontal motion, where we have v equals to u plus at, if the motion is vertical, that is motion under gravity, we are going to have it as v equals to u plus gt. Where we have v squared equals to u squared plus 2as, this will become v squared equals to u squared plus 2gs. And for horizontal motion, where we have s is ut plus half at squared, in a vertical motion, it will be s equals to ut plus half gt squared, because the acceleration of a vertical motion is known as acceleration due to gravity, which has a value of about 10 meters per second squared. Now, Since we are looking for the time taken for the object to return to the point of truth, that is, we are looking for the time taken for the object to go upward to its maximum height and then come back to where it was thrown. It means that we are looking for time, but let's bring out our parameters. In the question, we have that a stone is thrown vertically upward with an initial velocity of 15 meters per second. So, initial velocity U is 15 meters per second. We are looking for time of flight. Note that when an object is thrown upward, its acceleration is going to be equal to negative g, which will be negative 10 meters per second squared. If you take downward as positive, that is, we take the direction of gravity, which is always acting downward, we take it as positive. So if the object is going upward, it's going in opposite direction to gravity. So the acceleration is going to be negative t. Also note that when an object is thrown upward, when it gets to maximum height, the value of its final velocity at maximum height will be 0 meters per second. So let's consider upward motion alone. So a stone is thrown upward at maximum height. When the object gets to its maximum height, it's going to stop momentarily. It means that at maximum height, its final velocity is 0 meters per second. Now, let's find time it takes to get to maximum height. So we use V equals to U plus GT. At maximum height, the final velocity is 0. The initial velocity is 15. And we change this to negative because the acceleration is negative. The object is going upward. So this will be minus 10t. So at maximum height, we have 10t equal to 15. So t will be 15 over 10. That is equals to 1.5 seconds. So the time it takes for the object to get to maximum height to go upward alone is 1.5 seconds. Since the acceleration is constant, it's also going to take 1.5 seconds to come down. In fact, time of flight of an object projected vertically upward is 2t, because it's going to take the same amount of time to go upward and return back to the point of truth. So t is going to equal to 2 times 1.5. Then we have the time of flight to be 3 seconds. So it's going to take 3 seconds to return to the point of truth, to the point of projection. The correct answer will be C.